Good evening and welcome to a night lecture. It's a bit late here, 9:45, and I will make a continuation of my previous 1398A. I ended at page 108 in the marvelous book of Chiara Marletto, The Science of Can and Can't. And I ended at the first paragraph of page 108, so I will continue on the second one. Just give me this. All unpredictable behaviors were once supposed to be the same as in this game. Not objective, but tied to a specific viewpoint. And here Chiara is referring to the chance that before the appearance of counterfactual theory were considered to be subjectively and objectively random. But in constructor theory we make do with merely subjectively random. No longer does the randomness subside in the objective realm. If given complete information about the actual state of affairs, there is no unpredictability. The latter appears only if one has incomplete information. Though this belief might seem intuitively true, it was wiped out by the discovery of quantum theory in the first half of the 20th century. In quantum theory, unpredictability does not arise just from a lack of information. It is inherent to the physical world. Even when everyone has all the relevant information, it is objective. It is rather unfortunate that quantum theory has acquired in the collective imagination the status of a quirky beast. That is incomprehensible but worthy of attention because of its weird and bizarre demeanor. You may recall the words spooky action at a distance. Used by Einstein to describe quantum entanglement, or the creepy idea of locking a cat inside a box with poison. With catchy phrases, the press has promoted the view that quantum theory is destined to remain a complete mystery. Leaving the good old days of Newtonian physics behind, when the world used to make sense, we now have to resign ourselves to a new and alien picture of physical reality, which accords with the experimental evidence. But whose explanation of the universe is baffling? This is, in a nutshell, what it's about, is my comment. Experimental evidence, and impossible to explain in regular jargon or any jargon. None of this is even remotely fair to quantum theory. Yes, the quantum world seems bizarre and counterintuitive at first. But in reality, it is fascinating, subtle, surprising, and above all, not mysterious. It can be understood. The more it is understood, the more exciting it becomes. It is true, though, that quantum phenomena cannot be expressed entirely in terms of familiar analogies. As you are about to discover, there's a genuinely new, dazzling set of properties that quantum systems have, which are conceptually far from our everyday worldview. They are all based on a set of simple counterfactuals, which I shall now explore. Incidentally, quantum phenomena are important for the progress of our civilization because they allow for the enhanced information processing capabilities of quantum systems. Which outclass non-quantum information media, such as those deployed by the classical computers we use nowadays. The quantum counterfactuals are the fuel for the next technological revolution, the universal quantum computer. A universal quantum computer is a universal computer that relies entirely on quantum theory for its information processing. The computers we currently use are classical because they rely not on quantum phenomena to perform computations, but on entirely classical mechanisms. The theoretical description of the universal quantum computer has been around since the 1980s, and its features are very promising on paper. It has superior computational abilities compared with classical computers. Because its elementary information units can explore a much richer set of possibilities than simple classical bits. The effect of this richness which is entirely due to quantum physics effects, is that the universal quantum computer can be faster and more efficient than a classical computer when it comes to certain computational tasks. What is important here is for you to have in mind that the leap in possibilities that a universal quantum computer would bring about is analogous to that brought about by the introduction of the classical computers in the first place. It will make an entirely new class of technological improvements possible in the realm of information processing. Alas, the actual realization of a universal quantum computer has proved to be very challenging in practice. This enterprise has engaged some of the finest minds among physicists, engineers, and material scientists. Numerous IT companies such as Google, IBM, Microsoft, and startups as well are now trying to race towards the first viable prototype of this machine. but we are still quite a way away, even if we are getting closer. I belong to the cohort of people who look at technological developments in awe, with optimisms and high expectations, but are ultimately more interested in the foundations of the theories that allow such technology to exist. What is precisely about quantum media that makes them capable of supporting such super efficient quantum information processing? What can one learn by looking at the foundations if the technology is already pushing ahead? In fact, by digging into the foundations of quantum theory, we stumble upon a surprising fact. All properties of quantum systems, which are crucial for the universal quantum computer and the related quantum technologies, rest on a few elementary counterfactual features. In Chapter 3, I explained that information media are systems which attributes that can be flipped and copied. Quantum systems have these counterfactual properties and therefore are information media in this sense. But they have more counterfactual properties, making them so much more powerful. to see what these properties are and understand why quantum systems are a more powerful kind of information medium. I shall invite you to look again at the game of chance with cups, now through the lens of information theory. The two cups together with the marbles are, using the terminology of chapter 3, an information medium. They can contain a bit of information encoded in the position of the marble, as you can see in the figure on page 111. When the marble is under the cup on the right, it encodes the value 0. When it is under the cup on the left, it encodes the value 1. Let's see here, make some summary here.
Hey.
As you can see here, underlying this bizarreness and baffleness, as Chiara Marletto is referring to, is still a much simpler, yet I would say at the very outset even more baffling aspect, and it has to do with contradictions. When I started to address this strange approach of theirs, David Deutsch and Chiara Marletto, my first thoughts came to the French philosopher Jacques Derrida and his concepts of polarities, contrasting polars. They work together, but they are not rule-following contradictions. I think we normally make an exaggerated simplification and say that, there is such a feature in the world as to be contradictory. Simple feature. Black and white, right and wrong, true and false. Derrida takes a very close look at these. And under the surface, he finds quite another game, different from each taken opposition. they play out in their specific way, not reducible to a single rule. The play of opposites. Then my thinking came to Heraclitus, who saw opposition as the very foundational feature of what made becoming possible, what could make things stem into existence, what made them real, tangible, lasting. Life and death come together to make life. Winter and summer together makes warmth and coldness. Only together would that be possible. And this is a feature that been ignored all the way since Heraclitus, not clearly understood. We have become immune to opposites, no longer able to understand them, or as I got from Heidegger, use them, practice them, getting better at them. Instead, all oppositions are reduced to stable existences that could be grasped as an understanding by a stagnant observer or subject, very far from the lively quantum mechanics. This is a more living, and you never say you fully understand. Instead is this enticing and rewarding feeling of an energy flowing through the pages and flowing through your mind. This novel idea is, of course, closely connected to the quantum computer, who uses the counterfactual to the outmost limit. Of course, I'm very happy that they are now building 2 of those in my own hometown. It is very promising for the future that counterfactuals enter and develop most advanced piece of machinery ever to be produced in this world. Maybe some comments, or if it's too late. I'll give you some light as well.
Thank you, Hans. It's indeed great news for our city Gothenburg. Since January of this year, 2023, our town, Chalmers or Solmers, as you say in English, will have a quantum computer. It's not ready, but they have got funding for that, so they're working on it. That's great. I was thinking about this expression that you mentioned earlier by Einstein, spooky action at a distance, to describe entanglement. And Chiara Marletto indirectly criticizes Einstein, if you can say so, to use this spooky action at a distance, which is now normal entanglement. And then Chiara Marletto says, the creepy idea of locking a cat with poison. Do you see the contradiction? On the one hand, she indirectly criticizes Einstein for this phrase, spook at certain distance, but then she makes up her own variant. Spooky is almost an synonym to creepy. So she's criticizing Schrödinger also. Okay, so she's not very consistent. So it's that there is a trace, if you can say the Derrida phrase, a trace of a criticism of Einstein creeps into her own. She is trapped in a trap. But in one way, I understand this idea: spooky action at distance, and then creepy idea of locking a cat with poison. So creep is, of course, it goes under your skin. And creepy idea, it suits. It is. I think it's fair after all. A little bit unfair, but it's still fair. It is descriptive because the cat is in a creepy situation between life and death in a superposition. It's creepy. So it's one way, or you could even call it a ghostly idea. But so okay, I don't want to go in word games here, but I think it's still interesting. So let me go to the big picture with Chiara Marletto's book, which is Counterfactuals, which is synonym for processing, as I understood it. In other words, you mentioned Heraclitus. That is, of course, an excellent metaphor. So if you want to explain counterfactuals, that is processing, it's to refer to Heraclitus, that is everything flows panta rei. And so quantum computing shows the truthfulness of this expression by Heraclitus. So it's great. So where does the processing lie, so to say? For instance, Schrödinger's cat, you have this processing, what would we call it? It's always, I read Dirac a couple of months ago. He says that the whole reality is like collapses of superposition all the time. And in that way, its processing is like moving all the time. It's not. It's nothing. There is nothing. Nothing that is permanent. Everything moves from one way. So in this way, for instance, the idea of original is meaningless, or the original point of origin is meaningless, because everything, even the very first, if there is any very first grade, is based on other originals. So it's like like the idea of egg or the chicken, which comes first, is meaningless question. So back to you, Hans, if you want to add to my ideas. Thanks.
Yeah, thank you very much, Kalle, for that. It's much more creative, and my simple thought about this creepy experiment with the cat in the box, I was actually thinking more in terms of creepy in the way of killing a poor pet. But I like your much more creative. Maybe we can talk one day about creepy action at a distance. No, good. Yeah, I think we also need to bring in Edward de Bono, because he says at the heart of understanding is humor. So he doesn't see humor as a supplement, like a nutritious drink to make what you study or trying to understand more fun. He means humor is in the very center of understanding. But humor is, of course, counterfactual, and he meant, he started out, and this is a weird parallel that I think could be explored to some benefits. He started out saying that thinking itself is counterfactual. It goes against itself. It's like it has a syllogism, which is important, the structure, the form, and it gets broken. And at that very moment, which he calls the 0 point, everything is open. It's almost like a superposition. I don't know. It's late. I don't have any associations. But after that, there's a newness, a freshness. And that 0 position, that's humor in thinking. Makes you happy, but it's also creativity. And yeah, thank you very much. Have a very pleasant night. Good nighty night.
Good night. Thank you.